The strong nuclear force, of course, affects what's within the nucleus, but the electromagnetic force, which is less strong than the strong nuclear force, but still a very important force because it keeps electrons in orbit around the nucleus within an atom. So if atoms would not be a thing, if not for the electromagnetic force, right? The electron is opposite charge than the nucleus. See, protons have positive charge. They're made up of further divisible fundamental particles called quarks, and altogether, protons have a positive charge. Because this positive charge is attractive to negative charge of the electron, so then we have electrons and protons kind of staying together, kind of sort of staying together in the atoms. And we have atoms and we have neutral atoms, right? Otherwise, we would just have nuclei. And, depending on the temperature and depending on your energy regime, at higher temperatures and higher energy regimes, like back to when Big Bang was happening, there were no neutral atoms. So if you're just wondering about that, then just forget it. There were no neutral atoms back when Big Bang nucleosynthesis was happening, because things were too hot, too dense, too much energy at that time for electromagnetic force to do anything, and we did not have neutral atoms. But at the energy regime where electromagnetic force can operate, there electrons and nuclei are oppositely charged, so they attract each other. We get neutral atoms. Everything is nice and dandy. This is not always the case. Of course, things can get charged and lose an electron. That's actually how all of chemistry works, is the interchange and electrons going here and there and whatnot.